Welcome to the video on the invertibility theorem. In the last section, we discussed how the statement A is invertible is equivalent to the statement that the linear system AX equals B has exactly one solution for every B. So we saw how those two statements are equivalent, and what we mean by equivalent is that you can simply insert an if and only if between the two statements. And another way of seeing that, of course, is to think of the double implication, the double arrow. So that's the same as saying if and only if between the two statements. So those were two equivalent statements, and we're now ready to state and prove several equivalent statements to the statement A is invertible. And so if we read the theorem together, it's called the fundamental theorem of invertible matrices, or simply actually the invertibility theorem. It's another name. And so let's read it. If A is an n by n matrix, then the following statements are equivalent, i.e. for a given matrix A, they are all true or all false. And so if we say that the matrix A is invertible, a statement that is equivalent to that is the linear system AX equals B has exactly one solution for every B. That's what we saw in the last video. And that statement is equivalent to the homogeneous linear system AX equals 0 has only the trivial solution, right? So if we're using the same matrix A, but the system is homogeneous, then that unique solution will be the trivial one. That is equivalent to saying that the rank of A is n, the rank being the number of leading ones in its reduced echelon form. And that is equivalent to saying that the reduced echelon form of A is the identity matrix. In other words, A's are equivalent to I. So we're saying that all of these statements are equivalent to the statement A is invertible.
And that's where we're going to leave Theorem 5.6.1 for students in social science. You can omit the proof.